CVE-2025-30065 is a critical remote code execution vulnerability with a maximum CVSS score of 10, impacting Apache Parquet's Java implementation. The vulnerability exists in all versions up to 1.15.0 and allows attackers to execute arbitrary code simply by tricking systems into reading a maliciously crafted Parquet file. Parquet is a widely adopted storage format in the big data ecosystem and is commonly used by platforms like Spark, Hadoop, and Flink. Because these platforms often process data from potentially untrusted sources, this vulnerability poses a significant risk to organizations relying on these technologies. In this presentation, I'll walk you through the background and technical details of the vulnerability, demonstration of exploitation methods, a breakdown of affected products, and, most importantly, the mitigation steps and best practices you should follow to protect your data processing environments. Understanding CVE 2025-30065 is critical for anyone working with big data environments. This vulnerability falls under CVE-502, Deserialization of Untrusted Data. It specifically impacts the Java parquet-avro module in Apache Parquet. The attack is triggered when a Parquet file includes a malicious avro schema. Within that schema, an attacker can specify Java classes of their choosing. When an affected application reads this file, it ends up processing these classes, opening the door for remote code execution. All versions of Apache Parquet's Java implementation up until 1.15.0 are impacted. If you're running 1.15.1 or later, you're protected by the fix. This vulnerability doesn't just affect one platform, it puts a broad ecosystem at risk. Applications like Apache Spark, Hadoop, Flink, Hive, Druid, and Presto are all exposed. Even custom Java apps that import Parquet files can be vulnerable. The widespread use of Parquet files in handling data from potentially untrusted sources makes this issue particularly important to address. Let's break down how this vulnerability unfolds in real-world scenarios. The process begins when an attacker creates a specially crafted Parquet file. In this file, the attacker embeds an avro schema that includes a field configured with a default value. But here's the catch. That value references a Java class already present in the victim's application class path. When the victim's application, let's say a data processing job or analytics platform, reads and processes that Parquet file as part of its normal workflow, it unknowingly sets the stage for exploitation. As the file is processed, the avro library starts deserializing the schema. It attempts to instantiate the referenced Java class in the default value. Here's the dangerous part. If that class includes any static initializers or has a constructor with side effects, this code runs immediately as part of deserialization. Since the application is doing this with its own privileges, any malicious code inside the attacker-controlled class can execute. This could mean anything from launching network requests and dropping malicious files to running arbitrary system commands, all with the permissions of a compromised application. Understanding these mechanics highlights just how critical it is to never deserialize untrusted data, especially in complex data workflows that rely on widely used formats like Parquet and Avro. Let's break down the exploitation walkthrough for this vulnerability. Attackers start by generating a malicious Parquet file. They usually rely on proof-of-concept code that's publicly available, which makes this step relatively straightforward. The attacker compiles a payload class, along with an exploit file generator, and then uses it to produce the dangerous Parquet file. Next, the attacker delivers this malicious file to the target, potentially by sharing it through public repositories, email attachments, or other common channels. On the surface, this file appears to be legitimate data, nothing suspicious. The real danger happens when the victim processes the file. For example, running a command like java cplib/*out victim.parquet victim triggers the deserialization process. If the payload class is available on the class path, it gets executed automatically. At this point, any malicious code embedded by the attacker will run with the privileges of the victim application, which could allow data exfiltration, remote code execution, or other severe impacts. To test your environment for this vulnerability, there are a few effective approaches. F5 Labs has provided a canary exploit tool, which is specifically designed to help you check whether your systems are exposed. This tool generates a Parquet, or Avro file, that tries to instantiate the javax.swing.j editor kit class using a crafted URL. If your environment is vulnerable, processing this file will trigger a visible outbound HTTP GET request, making detection straightforward. In addition to active testing, you should audit all your Java projects for use of the vulnerable parquet-avro 1.15.0 library. You can do this quickly with the following commands. For Maven projects, run mvn dependency tree grep parquet-avro. For Gradle projects, use Gradle dependencies grep parquet-avro. These commands will help you identify where the vulnerable library is present in your codebase. Finally, leveraging software composition analysis or SCA. Tools such as Snike, Wiz, or Indoor Labs is highly recommended. These tools automatically map out your dependencies and flag any known vulnerable components, helping you prioritize remediation and stay ahead of risks in your environment. Let's look at core mitigation strategies for this vulnerability. First, the most effective and immediate action is to upgrade. Patch your systems to Apache Parquet version 1.15.1 or later as soon as possible. This removes the root vulnerability. Second, restrict which Java classes can be deserialized by setting the org.apache.parquet.avro.serializable packages property to an explicit allow list. Avoid using a wildcard, as that would reopen the vulnerability. Next, only permit trusted files to be imported or exported in your environment. Having strict data controls helps prevent attackers from introducing malicious files in the first place. It's also important to monitor for signs of exploitation. Be on the lookout for unexpected outbound network requests and class loading events, which could indicate someone is attempting to exploit this issue. Finally, education plays a key role. Train developers and analysts to avoid working with untrusted or suspicious datasets and to understand the risks of deserialization vulnerabilities. Remember, never set serializable packages equals *. Make sure your build files like pom.xml or build.gradle specifically require org.apache.parquet::parquet-avro: 1.15.1 or higher to ensure you're protected. This slide walks through a typical attack chain showing how the Parquet deserialization vulnerability can be exploited in real life. It starts at the distribution phase, where an attacker uploads a malicious dataset to a public repository or sends it directly to a target, masking it as legitimate data. Next, during the ingestion phase, a data engineer might unknowingly bring this file into their environment, processing it through Spark or a custom ETL pipeline. The real danger unfolds in the exploitation phase. If the Apache Parquet library used isn't patched, it will deserialize the malicious file's schema and, as a result, instantiate a class provided by the attacker. This step opens the door for compromise, which is the final phase of the attack. Here, arbitrary code execution can take place, potentially downloading malware, leaking confidential secrets from the environment, or even enabling the attacker to move laterally within the network. This attack chain highlights the importance of securing every stage of the data pipeline and why patching vulnerable libraries promptly is so critical. Here are the key takeaways from this attack chain. First, the vulnerability has a CVSS score of 10.0, which means it's considered critical and requires immediate action. The minimum safe version to address this issue is Apache Parquet 1.15.1, so it's essential to ensure your systems are running at least this version to mitigate the risk. This vulnerability is fully exploitable in any environment where untrusted Parquet data is ingested, making practical exploitation a real concern. As the quote here emphasizes, a single Parquet file can pierce your organization. That really reinforces the importance of auditing your data pipelines and promptly applying necessary patches. For more details and technical resources, you can look up NVD CVE-2025-30065, review tools like the F5 Labs Canary exploit tool, read advisories from Indoor Labs and Microsoft security guidance, and check out available proof-of-concept exploits on GitHub.